All right, welcome to lesson 10. In this lesson, we'll be solving equations, and it's a specific kind of equation we're going to be solving called linear equations. We're going to be focusing on equations with variables on one side, meaning on one side of the equal sign. All right, so a linear equation, those are the kinds that we'll be dealing with in this class. Linear equations have one variable, and there are no exponents on the variable. Eventually, when you make it, I believe, to part 2, intermediate algebra part 2, you'll start to see quadratic equations where there are exponents. But in this class right now, we just focus on linear equations. And generally, they have one solution. So a solution to an equation is the number that makes the equation true when that number replaces the variable. So before we dive into solving equations, let's just look at how to check if a solution actually works. So the first few questions on your homework will be something like this, where you'll be given a number and then you'll be asked, is it a solution? And what you do is basically plug it in and check to see if your equation is true or not. So here's our first couple examples of this. So the question is x equals 2 a solution to the following equations? So equation number 1 is 4x minus 3 equals 5. Now, I'm sure many of you recognize this kind of equation and maybe you're ready to just solve it. That's fine, but I would like to let you know that's not exactly the goal here. So what we are doing is we are actually checking a specific value of x to see if it works. And the way that we'll know if it works is if we get the same number, the same answer on both sides of the equal sign when we're done plugging in. So what I'm going to do is replace the x in this equation with our potential solution, which is 2. So again, the question is x equals 2 a solution to the following equation? So our equation 4x minus 3 equals 5, I'm going to replace the x with 2. So what I'm writing now is instead of 4x, I'm going to write 4 times 2. And then minus 3 equals 5. And I've put the 2 in parentheses. So again, instead of 4x, it's 4 times 2. 4x really just does mean 4 times x. All right, so what I have again is 4 times 2 minus 3 equals 5. My goal is to simplify and then figure out, is this actually true or not? So we're using order of operations over here on the left side of the equal sign, 4 times 2 minus 3. So I'll do multiplication next. 4 times 2 is 8. So now I'm writing 8 minus 3 equals 5. And now I'm going to simplify the 8 minus 3, which is 5. So 8 minus 3 is 5. So now the next thing I'm writing is 5 equals 5. What I've just done is I've just checked that. I've checked to see if 2 is a solution. And because I ended up with a true equation, 5 equals 5, then I get to say yes, x equals 2 is a solution. So, or in other words, yes, x equals 2. Okay, so the answer to number 1 is yes. Is x equals 2 a solution? Yes. Okay, because when I replace x with 2, it makes the equation true. What we're about to see in the second example is what does it look like when that's not the case. So here's our second equation. Now this one's a little bit harder than the ones we'll be solving today, but we're still going to check in this equation. So the equation is 3 parentheses x plus 1 equals 4 parentheses x minus 1. Once again, we're not solving right now. Our goal is to check, is x equals 2 a solution to the following equation? So I'm going to rewrite the equation exactly as it's written right above, only wherever I get to x, I will replace x with 2. So the first thing I'm doing is, you can see I'm basically copying down the entire equation from left to right, but I'm leaving a blank space where the x was. Okay, and then I'm replacing the x with 2, and that appears 2 different places in the equation. So here's what I have written next. 3 parentheses 2 plus 1, close the parentheses, equals 4 parentheses 2 minus 1, close parentheses. So I've replaced the x with 2. Now I'm going to simplify on each side of the equal sign, and we're going to find out if each side turns out to be the same. I'll start on the left side. I'm going to use order of operations. Inside the parentheses is 2 plus 1. 2 plus 1 is 3. And then I'll bring down the other 3. So right now on the left side, instead of 3 parentheses 2 plus 1, I just have 3 parentheses 3, which just means 3 times 3. So that's 9. So I'm getting 9 on the left side. Let's check the right side. On the right side, we have 4 parentheses 2 minus 1. So let's simplify inside the parentheses. 2 minus 1 is 1. Bring down the 4. So I have 4 parentheses 1, which means 4 times 1, which is 4. So it looks like we have 9 on one side of the equal sign and 4 on the other. So you can see I've just written 9 equals 4. That is not true. So I'm actually going to cross that out. This is actually not true. So I would say no, x equals 2 is not a solution. Or a shorter way of saying that is just x is not equal to 2. So I've just written x, and then I wrote an equal sign with a slash through it, and then 2. So the answer is no for this one. 2 is not a solution. There's another solution. We could find it. That's not exactly the goal. The goal for these couple of questions was just to practice checking an answer and seeing if it was a solution. This is something that you should do at the end of every equation. Once you get an answer, like x equals 2, then plug it into the original equation just to make sure that it does, in fact, make your equation true. All right. Good. So as we move on, then we'll actually get to solving equations. But I just want to make sure you understand what we just did here is what it looks like to check our answers at the end. All right. So let's get started with solving equations. So we're going to be solving equations that involve addition, subtraction, multiplication, and division, and sometimes all of the above. But we're starting off using something called the addition property of equality. So here's what this says. If A equals B, then A plus C equals B plus C. In other words, if you add the same number to both sides of an equal sign, the equation stays balanced. And the same goes for subtraction. If you add a negative number to both sides, that's subtracting on both sides, your equation stays balanced. So you're going to hear that word a lot, balanced. We want to keep our equations balanced. So we want to make sure that this equal sign is true all the way through. So whatever we do to solve an equation, we need to do it to both sides of the equation to keep everything balanced. All right, so we're focusing on addition and subtraction first. Here's number 1. X plus 4 equals negative 10. I would like to know what x is. There is one possible solution for what x could be. Some of you might take different approaches to figuring out what x is. You might be looking at it and trying different things in your head, and maybe you'll come up with the right answer, almost doing it in your head. The problems are going to get harder. It's important that you can show your work and show your process. So your goal will be to isolate x on one side of the equal sign. Isolate means to get it by itself. So over here on the left side, we have x plus 4. What I would like is to just have x. So how can we make that happen? Well, what we need to do, what we need to do is get rid of the plus 4. The opposite of plus 4 is minus 4. So I'm going to subtract 4. So I'm writing a minus 4 right underneath the plus 4. But this brings us back to what we were saying about equations staying balanced. If I subtract 4 on one side of the equal sign, I have to also subtract 4 on the other side of the equal sign. So now I'm subtracting 4 on the right side as well. So I've basically written minus 4 twice. I've written it on the left side as well as the right side. So we essentially have x plus 4 minus 4 equals negative 10 minus 4. The whole point of doing this, now I'm drawing a line underneath, is to cancel out the 4. I want that x to be by itself. Plus 4 minus 4, those are opposites. They add up to 0. Okay, so what I like to do is just cross them out. Okay, plus 4 minus 4, I'm just drawing a line through them. But the reason why I'm doing that is because positive 4 minus 4 equals 0. That's why you're going to see some things being crossed out when we show our work here. All right, so since I've crossed them out, since those terms canceled out, all that's left now is x. So now we have x by itself on the left side equals, now coming over to the right side, now we're going to combine the numbers that are there, negative 10 minus 4, and that is negative 14. So I'm getting x equals negative 14. This is our answer. This is a solution. Now to check it, I'm going to do that plugging in that we saw earlier. Okay, so I'm going to write down the original equation, x plus 4 equals negative 10, but we're going to replace the x with negative 14. So negative 14, negative 14 plus 4 equals 10. Now I'm going to simplify on the left side. Negative 14 plus 4, those numbers have different signs, so I would subtract and keep the sign of the bigger number, which is negative. So negative 14 plus 4 is negative 10 equals negative 10. So as I've plugged into the equation, I've gotten the same thing on both sides, negative 10 equals negative 10. So I'm writing a little check mark to say, yes, I checked it. My solution results in a true equation. Negative 10 is equal to negative 10. That is true. The solution that I just checked is negative 14. So x equals negative 14. That is the solution. But again, when you're checking, what you want to end up with is the exact same expression on both sides of the equal sign. All right, so that's number 1. We used the addition property of equality. We added, or in this case, we subtracted the same number on both sides of the equation. We subtracted 4 on both sides. Another way you could write that is adding negative 4. Okay, and we ended up with a solution of x equals negative 14. Let's try number 2. Number 2 is negative 7/24 equals negative 1/3 plus x. Okay, once again, we want to isolate x. I will write that down. Isolate x, or whatever your variable is. So isolate means to be by yourself. So we need the x to be by itself. All right, so whatever is near the x, we need to cancel it out. In this case, it's negative 1/3. So the opposite of negative 1/3 is actually positive 1/3. In this case, I actually need to add. Okay, so negative 1/3 plus 1/3, that will cancel out to 0. So I'm going to add 1/3 to both sides of my equation this time. So I'm writing it on the right and the left. This time, the thing that cancels out is the 1/3. Negative 1/3 plus 1/3 adds up to 0, so I'm crossing it out. Now, here's what we have on the left side. Negative 7/24. And then plus 1/3. Now, I'd like to rewrite this 1/3 because if I'm going to add these fractions, they're going to need to have a common denominator. So let's think about that for a second here. 24 is the larger denominator, so it would be nice if I could use that as my common denominator. And I can because 3 goes into 24. So again, I'm trying to add negative 7/24 plus 1/3. I know that to add or subtract, I need a common denominator. So I'm going to use 24 because 3 goes into 24. So my LCD is 24. I'm going to now take that 1/3, and since 3 times 8 is 24, I'm going to multiply by 8/8. So the 1/3 turns into 8 over 24. Now I can add the fractions. Negative 7 24ths plus 8 24ths, that's going to be 1 24th. Okay, and then meanwhile, I've brought down the equal sign. And because we had canceled out that negative 1/3 earlier, we isolated the x. So now we're done. So our answer or solution is negative 1 24th equals x. It's fine that the x is isolated on the right side instead of the left side. It's really the same thing. So either way, our solution is 1 24th. Okay, I'm out of space here, but I am going to take us to a blank page momentarily so we can see what the check looks like for this problem. We're going to check our solution. So negative 7 24ths equals negative 1/3 plus x. We're going to replace x with the solution that we got, which is 1 24th. So now we're checking. Okay, so negative 7 24ths equals negative 1/3 plus the solution that we got was 1 24th. Okay, and now again, remember to check. We're simplifying on each side and making sure that our answers come out to be the same thing. So what I need to simplify is over here on the right side, negative 1/3 plus 1 24th. Once again, I need a common denominator. I can use 24 for my LCD, my least common denominator. So I'm going to rewrite my fractions to have that common denominator. The negative 1/3, if I multiply by 8 over 8, that turns into negative 8 24ths. So what I have right now on the right side of my equal sign is negative 8 24ths plus 1 24th. And that adds up to negative 7 24ths, which is what I had on the left side. So it checks. Okay, so negative 7 24ths equals negative 7 24ths. Again, when we're checking our answer, we're replacing x, or whatever the variable is, with the solution. In this case, we replaced x with the 1 24th. And then we simplify on both sides if needed. And then at the end, we're trying to see if both sides of our equal signs are in fact the same. And in this case, they were. All right, good. So that was number 1 and 2 that dealt with the addition property of equality. Let's go back. And now we're going to take a look at some other sort of short equations. Most of these are 1 and 2-step equations so far. These next equations, instead of dealing with adding and subtracting, they're going to deal with multiplying and dividing. So the property we're going to use is now called the multiplication property of equality. So here's what this one says. If A equals B, then A times C equals B times C. Okay, keep in mind that C could be a fraction. So A times 1/2 equals B times 1/2. Well, multiplying by 1/2 is really the same thing as dividing by 2, right? So A divided by 2 equals B divided by 2. In other words, what I'm trying to say is the multiplication property really is the multiplication and division property. Just like adding and subtracting really go together, same thing with multiplying and dividing. So here's what the next sentence says. If you multiply or divide by the same number on both sides of your equal sign, the equation stays balanced. All right, so the next few examples will involve multiplication and division. We still want to isolate x, get x by itself on one side of the equal sign. For these next few problems, instead of adding or subtracting, we're going to be multiplying or dividing. And whatever we do, we're going to do it on both sides of the equal sign. So here's number 1, 9x equals 63. So 9x really means 9 times x. So there's multiplication happening here. To isolate the x, to get the x by itself, I don't want the 9 to be there being multiplied. I would like to get rid of it. So think about the opposite of multiplication. That would be division. So I'm going to divide both sides by 9. And I tend to write this almost like a fraction. Okay, so I'm drawing a line under the 9x and then writing 9 underneath. So it looks like 9x over 9 equals 63 over 9. The reason why we're able to do this is the 9 divided by 9, that cancels out. And the way it cancels out is any number divided by itself is equal to 1. So really, 9x divided by 9 is the same thing as 1x. But I'm just going to write x. You don't really need to write the 1 there. But just keep in mind when you're crossing things out like this, for multiplication and division, when things cancel out, they're canceling out to equal 1. Okay, so 9x equals 63. We're dividing both sides by 9. 9x divided by 9 is just x equals, and then 63 divided by 9 is 7. So x equals 7. Now we can do a quick check here. Checking that solution of x equals 7. I will rewrite the equation, but instead of 9x, I'm writing 9 parentheses 7. In other words, 9 times 7. Okay, so instead of 9x equals 63, I'm writing 9 times 7 equals 63, which is true, right? 9 times 7, so I'll write 63 right underneath, equals 63. So it checks, it works. When we replace x with 7, we get a true equation. That's it. All right, so that one, we divided on both sides of the equal sign. For the next two problems, we're actually going to be multiplying on both sides. So for number 2, here's what it is. Negative x over 2 equals 4. All right, the x is already being divided by 2. So the opposite of dividing is actually multiplying. We need to multiply in this case. Okay, so compare it to the one we just did where we started off with 9x and we had to divide by 9. This one, we're starting off with x divided by 2, so we can then just multiply by 2. Also at the same time, there's this negative sign. We don't want that to stay there in the final answer. We don't want negative x, we want just x. So here's what we can do to take care of both of those things all at once. We can multiply not just by 2, but we can multiply by negative 2. So what I'm doing is I'm putting the negative x over 2 in parentheses, and then I'm writing a negative 2 off to the side like I'm multiplying. So I'm multiplying the left side by negative 2, and then I'm also doing the same thing on the right side. So again, the original problem was negative x over 2 equals 4. I want that x to be by itself, isolated. So there's really two things I'd like to cancel out here. I'd like to cancel out the 2 in the denominator, and I'm doing that by multiplying by 2. And at the same time, negative times negative, those will cancel out to become positive x. So I'm canceling out the 2's, and in a way, I'm also canceling out the negatives. Negative times negative is positive. All right, so I've isolated the x on the left side. Meanwhile, on the right side, since I multiplied by negative 2 on the left, I'm also multiplying by negative 2 on the right. 4 times negative 2, that's negative 8. So my solution is x equals negative 8. Here's what the check looks like for this one. Okay, so negative x over 2 equals 4, except instead of putting x up there in the numerator, I've left a blank space. I'm going to put our solution, which was negative 8. So this looks a little strange right now. I have negative, then a fraction, but in my fraction I have negative 8 over 2. Maybe you'll even choose to put the negative 8 in parentheses when you do that. So it's negative 8 over 2, and then equals 4. So negative 8, that's kind of strange to hear it said like that. It's kind of like negative 1 times negative 8. The point is it cancels out to become positive. This is now just positive 8 over 2 which is equal to 4. 8 divided by 2 is 4, so 4 equals 4. So the solution does check. It's a little strange when you're plugging in a negative number for x and there's already a negative sign there. It's an easy thing to get mixed up. But just notice I kept the negative sign that was already there, and I replaced x with -8. So both of those negatives canceled out to give us that positive when we were checking. All right, number 3 also involves fractions. 3/4 n equals -1/8. Because I'm a little tight on space here, I'm going to work this out again on the whiteboard. So I'll switch over to that again. All right. So this is number 3. 3/4 n equals -1/8. All right, so let's think about what's happening here. 3/4 n. 3/4 is being multiplied by n. So in a way, what we could do is divide both sides by 3/4. That's going to look a little awkward if we try to write it as another fraction. I'm going to do it and then quickly erase it. But here's what it looks like if I divide by 3/4. I'm putting the whole thing over 3/4. It does not look very pleasant. It's starting to look like there's multiple layers of fractions, and maybe that's not the best way to go. But the truth is we do somehow need to divide by 3/4. But remember, when you divide by a fraction, what we can do is actually multiply by the reciprocal. So here's what we can do. When we're dividing by 3/4, really what that means is we're going to multiply by 4/3. Okay, so we're multiplying by the reciprocal. Multiply by the reciprocal. It's going to cancel things out really nicely. So here's what I'm going to do. To isolate the variable, which is n in this case, because we have 3/4 times n, I'm going to divide by 3/4, which really means I'm going to multiply by 4/3, or 4/3. So what I'm doing is, in parentheses, I'm writing 4/3 on both sides, because I'm multiplying both sides of my equation by 4/3. Take a look at this, 4/3 times 3/4. Hopefully you can see that the 4's are canceling out and the 3's are canceling out, right? We can do that kind of cross canceling, 4/3 times 3/4. Those are reciprocals, so of course they're going to multiply to 1. All right, so let's do our canceling. 4/3 times 3/4. The 4's cancel out to equal 1. So 4 divided by 4 is 1. And then same thing with the 3's. The 3's cancel out to equal 1. So you're left with just 1n, or n, on the left side. So that pretty much achieved our goal of isolating the variable, which is n in this case, because 4/3 times 3/4 is just 1. Now, if you didn't reduce and just multiplied straight across, you would have gotten 12/12, which is still 1. Okay, so either way, it's just 1n, or n, left on the left side. Meanwhile, on the right side, -1/8 times 4/3. You can multiply across and then reduce, or let's just reduce right now. -1/8 times 4/3. The 4 and the 8 can reduce because they have a common factor of 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So now it sort of looks like I have -1/2 times 1/3. And when I multiply across, -1 times 1 is -1. And then 2 times 3 is 6. I wrote 3, but I meant 6. Sorry about that. There we go. So I'm getting -1/6. Now you can see, based on my handwriting, I almost can't help but just write the negative sign in the numerator of a fraction, but I could also write it pretty much off to the side. It really does not matter. When you type your answer, you might see it looking either of these ways. It really doesn't matter. You might not have even thought that there was a difference, and there's really not. So the answer is -1/6. Whether you put the negative off to the side or in the numerator, either is fine. I think even the denominator is fine. Okay, so our answer is -1/6. So now you can see that yes, fractions can happen. You can get solutions that are fractions. And let's finally check our answer. So I'm moving to another blank page to do that. So we're going to check our solution. Check. So I'm copying down the original problem, 3/4 n equals -1/8. The solution we got for n was -1/6. So now I'm writing 3/4 times -1/6 equals -1/8. And now I'm going to simplify over here on the left side, 3/4 times -1/6. It's definitely going to be negative. If I multiply straight across, I would get -3/24, but then I would need to reduce it. So I'd rather just reduce first. The 3 and the 6 can cancel out by dividing by 3 in the numerator and denominator. So 3 divided by 3 is 1, 6 divided by 3 is 2. When we multiply straight across, 1 times -1 is -1. 4 times 2 is 8. So we are getting -1/8, or -1/8 on the left side, which is equal to -1/8 on the right side. So it works. Okay, so if you reduced later that -3/24, you'd still need to divide by 3 in the numerator and denominator to reduce. Okay, so that's what it looks like to check our answer. All right, good. So what we've seen so far are these pretty much one-step equations where we're doing one operation on both sides. We've seen adding, subtracting, multiplying, and dividing, and we've also seen checking. What we will now move on to is some longer equations that are called multi-step equations. Okay, so I have a long list of steps here. You will not always need to use all of the steps, but this is a list you can refer to if you're not really sure where to start. So multi-step equations, steps for solving. Okay, so step 1, eliminate fractions, multiply both sides by the LCD. We're not there yet, but we will eventually see some equations that have not just one fraction, but several fractions. So what we will need to do is find a common denominator and then multiply each term by that denominator, and that will help us to eliminate fractions. So that's something we're going to be getting to. Step 2, if there are parentheses, eliminate parentheses. So we will be using the distributive property. Okay, so that's going to come up quite a bit. Usually after you distribute, that brings us to step 3, combine like terms. And the full sentence is combine like terms on the same side of the equal sign. So keep those sides separated, but if there are like terms, you'll want to combine those. Then we'll start doing our work to isolate the variables. So generally next would be adding or subtracting. So the equation is in the form ax equals b. So you're working on isolating that term that has the x. So if there's kind of extra numbers nearby, you could add or subtract on both sides to cancel them out, which is what we've seen already. Usually the last step is to divide, sometimes multiply. So step 5 says multiply or divide to isolate the variable. Okay, so if it's ax equals b, that a, you would need to divide by a on both sides. Or if it's 2x equals 10, you'd divide by 2 on both sides. That's a pretty common way for equations to end. And then our final step, step 6, check the solution in the original equation. Now, I'll be honest, I don't always bother checking because we're tired by the end of the problem, right? But I'm trying to be a good example here, and I've shown you how to check your solutions along the way by plugging in your answer for x and then simplifying to make sure both sides of the equal sign are the same. So you have a fully worked out example written right below, and then you have the check next to it. So let's take a look. Here's our example. 2a plus 3 minus 8a equals 8. Okay, something you might consider doing is, it's not going to be a perfectly straight line, but you can kind of draw a line down the middle of your problem. I'm kind of drawing it right through the equal sign, just to really emphasize the fact that there are two sides to your equation, okay? So sometimes it's easy to get mixed up and bring something over to one side when you really shouldn't. So feel free to draw that line down the middle, and I might do that sometimes as well. And once you do that, then you can focus on one side at a time. So over here on the left side, you can see the 2a and the minus 8a, those have been underlined because those are like terms. 2a minus 8a is negative 6a. And then the plus 3 just comes down. So the next line that has been written is negative 6a plus 3 equals 8. Okay, so here's what happened so far. Just make a little note here. Okay, so we combined. Say we combined like terms or collected like terms. So you can see that was step 3. We didn't have to do step 1 or 2 because there were no fractions and there were no parentheses in this problem. So we combined like terms. And then the next thing that happened is, let's see, we had negative 6a plus 3 equals 8. We had to get rid of that plus 3. So what we did is subtract 3 on both sides. So that's that minus 3 on both sides. Minus 3, minus 3. The plus 3 and minus 3 then cancel out to equal 0. So you have negative 6a, that's all that's left on the left side, and then over on the right side, 8 minus 3 is 5. So negative 6a equals 5. Finally, the last step here is to divide. So that's what's happening right here. It kind of looks like a fraction where things are being put over negative 6. We were dividing both sides by negative 6. Negative 6a divided by negative 6. The negative 6's cancel out and you're left with just 1a or a. On the right side, 5 divided by negative 6. It's just a fraction that you can't reduce, so just leave it as negative 5/6. All right, so generally fraction answers are what we prefer as opposed to decimals. If the original problem starts off with decimals, you might get a decimal answer, but usually if you're not really sure, leave it as a fraction. Okay, and then you can see over here with the check, the original problem has been written, but instead of a, there's parentheses, and the solution has been plugged into those parentheses. So the check looks like this. 2 parentheses negative 5/6, close parentheses, plus 3 minus 8 parentheses negative 5/6, close parentheses, equals 8. And now we basically simplify all the way down to see if both sides are in fact equal. So here's what's happened. 2 times negative 5/6, if you put the 2 over 1 and multiply across, the 2 and the 6 get reduced to 1 and 3, so it becomes negative 5/3. Let's see what's going on over here with the minus 8 parentheses negative 5/6. Negative times negative is positive, and then the 8 and the 6, if you put the 8 over 1, 8 and 6 have 2 in common, so I'm crossing out the 8 and writing 4, crossing out the 6 and writing 3. Now, when we multiply across here, this negative times negative is positive, 4 times 5 is 20, and 1 times 3 is 1. So here's what we have so far, putting it all together. Negative 5/3 plus 3 plus 20/3, or 20 over 3, that's what we just worked out, equals 8. Now to keep going, looks like the fractions were added together. Negative 5/3 plus 20/3, that's 15/3. We had a common denominator. And then from here, it finally gets simpler. 15/3, that's just 15 divided by 3, which is 5. So you have 5 plus 3 equals 8, and then yes, 8 equals 8. So I think this is a good example where the check was maybe longer and more annoying to do than the actual equation. So I don't blame you if you don't check every single time. You might just click check answer on the MyLabs Plus homework, but it is very important to be able to check if you need to. All right, good. So that one was already worked out for us. Let's do a couple on our own and see what this feels like. Okay, so I'm moving to the next slide. Number 1 is 2x plus 4 equals 10. And the directions at the top say solve the equations and check your solutions. All right, if you refer back to your steps, that long list, step 1 was eliminate fractions. We're not going to see that yet. Step 2, eliminate parentheses. No parentheses here. Step 3, combine like terms on one side of the equal sign. Okay, we can't do that, okay? So the 2x plus 4, those are not like terms. Here, let me draw that line down the middle of my problem. Okay, so if you're wondering about the 4 and the 10, I can't combine them because they're not on the same side. So that brings us to step 4, add or subtract. So the equation is in the form ax equals b. All right, if I'm trying to isolate x, I'm going to circle where the x is. It's right over here, 2x. Before I can isolate x, I really need to isolate its term, which is 2x. So the first thing I'm going to do is get rid of this plus 4. The opposite of plus 4 is minus 4. So here we go. Here's our first step, minus 4 on both sides. Plus 4 minus 4, that cancels out. So here's what we're left with, 2x, that's all that's there on the left side, and then equals, on the right side, 10 minus 4 is 6. So I have 2x equals 6. Now we're really just one step away from getting the x by itself. Now we get to multiply or divide, and in this case we will divide both sides by 2. And I'm writing it kind of like I'm putting it over 2. Oops. All right, so 2x over 2 equals 6 over 2. The 2's cancel out because 2 divided by 2 is 1, so I'm left with just 1x equals 6 divided by 2 is 3. Now I say 1x, I'm not writing the number 1, I'm literally just writing x. So x equals 3. That's it, we did it. And here's what the check would look like. Check. 2x plus 4 equals 10. So instead of writing all that out, I'm replacing the x with the solution that we got, which is 3. So I'm writing 2 times 3 plus 4 equals 10. And now we'll simplify on both sides. 2 times 3 is 6. So I'm writing 6 plus 4 equals 10. And then, yes, 6 plus 4 is equal to 10. So 10 equals 10. And it checks. So I write a little check mark at the end. Okay, so that problem was pretty much just 2 steps. I had to subtract 4 on both sides and then divide by 2 on both sides. And then we checked. All right, next problem, a little bit longer, number 2. Negative 5r minus parentheses r plus 6 equals 3. Okay, so here is a problem where I do need to eliminate parentheses. So when you see parentheses, get ready to distribute. Let's take a look at what we need to distribute. The thing in front of the parentheses is just a minus sign. Treat it like a -1. So what we're going to do is distribute a -1 into the parentheses. So -1 parentheses r plus 6. Here's what we're going to write right below. -1r. You can just write -r, but I do like writing the 1 here. I think it's going to help in a minute here. I don't like to write the 1 in the final answer, but in the middle of a problem, it can really help. So here's what I've written so far. -1r, and then -1 times 6, that's -6. Now I'm copying everything else down. So here's the entire problem copied down. -5r. And then next is what we already did, -1r minus 6 equals 3. Okay, so we eliminated parentheses by distributing. Now we will combine like terms. The like terms on the same side of the equal sign are the r terms. -5r minus 1r. -5 minus 1 is -6, so I'm writing -6r. So here's where we are next. -6r minus 6 equals 3. Okay, -6r minus 6 equals 3. So now I'm going to start isolating the r. All right, so remember last time how I circled the 2x? Now I'm going to circle the -6r. Isolate that term. So the next thing I'll do is I need to cancel out this -6. Oops. I need to cancel out this minus 6, and the way I'm going to do that is by adding 6 to both sides. So we'll write plus 6 on both sides. Okay, so minus 6 plus 6, that cancels out to 0. Here's what we have next. Negative 6r equals, now on the right side we have 3 plus 6, which is 9. Okay, so negative 6r equals 9. Keep going, there's one more step. To get the r by itself, we need to get rid of this negative 6 that's right in front of it being multiplied. So the way we're going to do that is to divide. So let's divide both sides by negative 6. So I'm putting things over negative 6. All right, negative 6r divided by negative 6. So negative 6 divided by negative 6 cancels out to 1. So that's just 1r, or just r is how I will write it. So r equals. On the right side, we have 9 over negative 6. Okay, this is clearly a fraction. Let's reduce it. 9 and 6 have a common factor of 3, so let's divide them both by 3. So 9 divided by 3, that's 3. 6 divided by 3 is 2. So I have 3 over 2, and then see how the negative sign was in the denominator because it was with the 6? I'm just going to write it off to the side. So my answer is negative 3 over 2. So r equals negative 3 over 2. Okay, next what we're going to do is check our answer. Okay, I know you can just click check answer on the homework, but the more practice, the better here for checking our answers. Okay, so especially with fractions. Here's the original problem. Negative 5r minus parentheses r plus 6 equals 3. We just got negative 3 over 2 as our solution, so we are checking this. So now I'm going to rewrite the equation. Each time I see the letter r, I'm going to replace it with our solution, which was negative 3 over 2. All right, here we go. So negative 5 times negative 3 over 2 minus parentheses negative 3 over 2 plus 6 equals 3. All right, so let's see what we need to do here. Negative 5 times negative 3 over 2. If I put that 5 over 1, we can multiply across. This becomes positive 15 over 2 minus. Meanwhile, inside the parentheses, negative 3 over 2 plus 6, I need to add those and get a common denominator. So I'm putting the 6 over 1. If I multiply by 2 over 2, that becomes 12 over 2. So inside the parentheses now is negative 3 over 2 plus 12 over 2. And then it's all equal to 3. All right, keep going. So I'm going to continue to simplify inside the parentheses. Negative 3 over 2 plus 12 over 2, that's equal to 9 over 2. So here's what we have so far. 15 over 2 minus 9 over 2 equals 3. We're a couple steps away. 15 over 2 minus 9 over 2. Okay, 15 minus 9 is 6, and we can do that because we have a common denominator. So 15 over 2 minus 9 over 2 is 6 over 2 equals 3, and then yes, 6 divided by 2 is 3. 3 equals 3. It checks. Okay, so our solution works. It checks out. Our solution is negative 3 over 2. All right, I'm going to bring us back now to the PowerPoint. This is probably the point in class, if we were in a regular class, that we would probably take a little break at this point and maybe take a look at the classwork packet and try a few of the shorter, easier problems, maybe try some on your own. Now's a chance to ask questions, etc. And then we would come back and pick up where we left off and see some of the harder problems. So I'm going to do that in a part 2. I'll do a separate video. There's only 3 problems left, but they're fairly involved, okay? So what we have not yet gotten to is solving equations with fractions and decimals and being able to eliminate those. Sometimes it's called clearing fractions and decimals. So I'll just give you a quick preview. I'm going to end here and then come back at you with a part 2 for this lesson. All right, so here are the 3 problems we haven't done, but we will in a separate video. So number 3, 0.7y minus 0.4y equals 1.8. I want to talk about clearing the decimals. Number 4, this is a fraction one, multiplying by the LCD, negative 5/3 x plus 2/3 equals negative 11. And then number 5, 3/4 x plus 3/8 x equals 45/8. Okay, so give yourself a break. Maybe go start the homework for lesson 10, kind of get comfortable with the earlier problems, and then come back and watch part 2 so you're ready for these later problems. Okay, good. So I'll see you soon for lesson 11, part 2. We're not done. Take a break. Come back for part 2. All right, see you soon.